Hello everyone, welcome to my tutorial channel, and I would like for you guys to please like my channel, subscribe, and uh, share these videos I'm doing to your friends so I can get more views, and more views mean encouragement to make more videos like these. So today's topic will be on seismic forces. So if you're designing a building in a highly seismic zone, you want to know the seismic forces, how to do it. The manual is there, but you know, you know where to look. That's another thing. So here, here we go. Now you need two very important things. Well, multiple things, but before you even get to other things, you need this CS. Right, C sub x is the seismic coefficient factor, if I'm not mistaken. Response coefficient, okay? Seismic response coefficient, okay? So you need that. Um, that's the formula there, and then you have some, restraints here, So you also calculate these to make sure that value stays between these. All right. So that's your CS. Now C sub x. Now you use that into this equation here, get your equivalent lateral force. I mean your base seismic base shear. All right. So here, let me clarify one thing. I'm using the equivalent lateral force procedure. Okay. Equivalent lateral force procedure. That's what I'm using. All right. So chapter 12, 12.8. If you read through, you will find all these equations and all the requirements you need to get your value, right? R is the response modification factor. You can find it in table 12 in this chapter. It's up there. You find it first before coming here. So I important factor also tells you where to find it. Okay, so chapter 11, that 5.1. Okay, so get all those and then come in here and use this formula. Now, where to get SDS, I'll show you in a moment. Okay. Now, this R factor, like I said, oh no, yeah, like I said, you can find it in this table right here. Okay. This table here. Now, the table is kind of in portrait mode, but anyways, this is what bearing wall systems. Well, we're not doing bearing. I'm doing a building frame system. Okay. So let's say mine is still ordinary concentrically braced frame, right? So if I scroll up, my R factor is 3.25, right? I also have the overstrength factor, which is 2, and I have the deflection implication factor, which is 3.25 as well. Okay, so all those values, you need them in your design to come this in this table and get them. All right. Now, and once you have those, you can use these equations out here. That 12.3, that's 4. You have all these equations, seismic load effect, all these equations here. You can use them to do your load combination. Okay. So you see the R factor, I mean the omega overstrength factor there. Um, and that R factor, we'll use it in a second. Okay. All right. So this is where to go. Chapter 12.8. Okay. Now I've made an Excel sheet right here that we're going to use to do a, I mean, go fast. This is a pre-made Excel sheet that I use at work sometimes. To determine my things. So I keep this on my desktop. Anytime I have something that just plug in the values, it calculates for me. Okay. Now, ASE has done a really good job, and like I said, I have all these equations written, so I know where to find them. So they have a website where you can find all those values. You know. So first, how to get your values? ASE 7 hazard tool. Okay. Now if you come in, type in your address, your site address there, you know, click search, it will show you. And then also risk category, which risk category it is. Let's see, what does this thing say? So risk category, you'll find it also in the manual. I don't sorry, I didn't tell you where to find it, but it should be in the, it is in the ASC 7 manual, so you'll find that there. um, so basically that is, what type of building you designing. If it's an industrial, hospital, school, whatever, there's a description. Actually, I've talked about that in a previous video, I think in the wind load determination, the first video. So if you go there and watch it, you'll see how to find that there. Steve's the site class here, basically in your geotech report, they'll probably tell you what type of soil is there. So you can, put that, input that here. If you click on the drop down, you have all these. Click whatever. So I'm gonna use site class D. And you can determine the wind load, ice load, rain, tsunami, tornado, flood, snow, seismic. I'm doing seismic. I'm not gonna be worried about all these here. Um, but if you actually trying to see which force controls, you might want to check all that, like when, probably, when is another thing in this San Francisco area. Maybe, I'm not sure, but I think seismic will control here. So I'm gonna do seismic here, because wind, I already did wind in some other videos, so you can check that out and see. Now once you click that, you can click view results. Okay, you click the results, you have to check this button here, you know and then it will show you. Okay, if you come down here, you have all um, the colors will show you which point is like maybe worse and all. So you have all that there. You can click full report, you can click summary, you can click detail. If I click detail, for example, right, before I couldn't find these here while I was using the ATC website. um, but yeah, they then it show me all the graph and all, but this ASC update, or they have all these graphed already. So you have all that there, and then they have all the values you can find in the manual as well. These like S1, SS, and then you can use this to calculate SDS and SD1. TL, you usually probably, yeah, there is also TL, you can find it in there. SMS, there's an equation to calculate that. SM1, you can calculate that as well. All that is in the manual, but here, once you put your address, yeah, everything comes up. So you don't have to, like, there's a whole procedure that you cut off, you know. And also you probably, I mean, if you being very sort of I don't know, you can try to verify that this information is your history using the ASC manual as well. So just to like check yourself, and back check everything. So, but in this example, we'll just use these values here to do it. Now, if I click summary, same thing. And now it will show me latitude, longitude, elevation, the area, all that, risk area, site class, and all those information as well. Okay. Now that I have all these, let's go to my Excel sheet. And yeah, like I said, see, I have all my graphs remade. So if I didn't have that, all those values, then I'll go through all these, all these, to determine all these like SS, S1, and then use that to calculate my SMS, which is FA times SS. Now FA, you find it in this table in chapter 11. Okay, like I said, chapter 11 and 12, you find information there. So find this, and then depending on your site class, you find the FA value, site class and SS, and then you calculate use that equation, calculate the SMS. Same thing for SM1, find FV, and you multiply it by S1, get your SM1. Okay, now I blacked everything out because I don't want you guys to be using those values because we're going to skip all that and go. Yeah, so same thing. Then you calculate your time period, SA, all that, and then plot the values. But the time period, I think we'll start here in this example because that one really depends on the time period really depends on your city value, X, height of the building, and CU. Okay, so here let's say our building is what 100 feet tall. Okay, 100 feet tall. I put 100 feet there. Let's find CU. Okay, so here if we come in this table in chapter 12, 12.8-1, provision for upper limit on calculated period. So that would be CU, right? Now, here we have value for SD1, right? What's our SD1? Let's check our SD1. So we'll go back to the thing there. Our SD1 is 1.17, right? 1.17. So for any value more than that, your CU is 1.4. Okay, so I guess most of the projects I've been doing, they're always that 1.4. So I have 1.4 there. Now CT, where can we find our CT value? All right, table 12.8-2, right? Right there, CT and X. Okay, so moment resisting frame. No, we're not doing moment resisting frame. Still eccentrically braced. We're not doing eccentrically. We're doing concentrically braced. Okay, still buckling wrist. No, we're not doing that. We're doing all other structure system. So we have 0.02 and then 0.75 for X, 0.02 for CT, 0.75 for X. So if you can hear 0.02, 0.75, plug that in, automatically calculates it. So basically use applying that formula here. So our T is 0.89 second. Okay, that's our T. 0.89 second. Now skip all these graphs because like I said, I don't have the right values plugged in here because we're doing this example, we're skipping all these. Okay, all right, so we could get to our base here, but before that we have to calculate CS, right? We have to calculate CS, C sub X, which is in the ASE manual like I showed you right here. Where is it? All right, right there. So that's your C sub X. Same formula is here. That's what we're applying. Now our important factor here is 1. We're using 1 for this example. And now our R value, like I said, it was 3.3 and a quarter, right? In that table in chapter 12, 3 and a quarter. It's our R value in this table here. This table, steel ordinary concentrically braced frame. Right, that's our R value there, right? 3 and a quarter. Right, okay. So 3 and a quarter, I have it there. Now I can apply this formula to get my C sub X, right? So my C sub X will be 0.32, right? 0.32 because if you do SDS, what's our SDS? Actually, it's, yeah, I'm wrong. Our SDS here is 1.16, right? Our SDS is 1.16, so let's put 1.16 here. And then what's our SD1? TL. Let's do all these yellow. Oh, this should be black, and this should be yellow. Okay. All right. Now SDS is 1.16, SD1 is 1.17, TL is 12, right? SD1 1.17, TL is 12. Now what's S1? Let's find S1. 0.6. So S1 is 0.6. Right there. So we have all our values entered. Now T is that 0.89 that we calculated above over there. So plug it in there. Now that you have that, our C sub x, it will be SDS, which is 1.16 divided by um, R over that. So will be basically 1.16 divided by 325. So let's see. 1.16 divided by 3.25. Yeah, 0.3569. Why is it not changing here? Yeah, my SDS, the value is not changing because it's not using this F284. Should be F284. That's why you have to be very, sorry, 285. You have to be very careful when you're using Excel sheets like that. So yeah, 9 is still correct. I have this Excel sheet, but I also use my calculator a lot to back check all these formula, make sure I'm not using some other value I'm not supposed to. So all right, so that's our C sub x there. Now there are constraints. Okay, there are constraints. You have to check that value cannot be less than this value here, which in turn cannot be less than this. Okay, so let's calculate this 0.044 SDS IE to see what that value is. Okay, so there we have 0.044 D95. What is D95? Yep, it shouldn't be D95, should be this. D95 should be SDS right here times IE, which is this. So that's correct. Now our minimum of C sub x is 0.051. Alright, so that is more than this. So that is good. Now our maximum C sub x, just like in the ASC, I copied this page and pasted it here. So maximum says the value of C sub x computed in accordance with this equation does not need to exceed the following. So this is the maximum here. If for t less than TL, our t is what? 0.89 and TL is 12. So we are in this. We're using this equation. This is what C sub x should be. The maximum should be. So it should be SD1 over R divided by E times T, right? So let's see our maximum value. SD1, yeah, we got SD1 here divided by that, the violet, times T first. All right, our T here, which is F that 286 times C 275, which is that, okay, divided by C 277, which is this. Okay, so we're good there. All right, so our maximum value is 0.407. Okay, so since this value is more than this value, we're good there, and the maximum is more than the actual CS. So our final CS that we'll use just to be conservative will be the maximum of CS value. That cannot be, if this were more than that, then we'll just use this. Now that this is less than this, we'll use this. Yeah. So basically, you're trying to maximize it, right? but you also don't want to over maximize, I guess. So we use this as our CS final, right? So now we have that, right? So like I said in this video, we'll use these. There is no, you can't use live load in there. So even though this is here, it's not being used in uh, these calculations. Okay, that's just a table. I'm gonna black it out. Okay, black it out right there. Okay. So I put like dead load 50 pound per square foot per floor. Okay, so you have all these floor here, and then you have each area of the floors, right there. So basically, we're calculating all that dead loads. This is what they, when you multiply those load times the square footage, you get this. Now you have, you know, equipment, boiler, FT fan, SRC, some stuff like that. So you add all these mechanical loads to the dead load of the structure, and then you get your loads. Now, like I told you, that will be total of these weight. Here will be your seismic weight. Okay. Now, how to get your base shear? Base shear is what? C 375, right? Or is C 375? It's not using, yeah, it's not using my C sub X to do it. So